Good evening, or good afternoon, and soon to be good evening. Lord Browne, there you are. Colleagues, ladies and gentlemen, thank you very much for joining us, and a very warm welcome to the Royal Academy of Engineering. And for those of you who had any trouble getting here as a result of Piccadilly Circus being shut, you know the importance of transportation in good city design. And we, with our new refurb of our fantastic building here, will, of course, be tackling the issues of sustainable cooling. My name is Paul Westbury. I'm the Chief Executive of Buro Happold, so I run an engineering company. I'm an engineer myself. I trained as an engineer. I've been working as an engineer for about 20 years now in professional business, and I'm also a fellow of the Academy. So it gives me tremendous pleasure to be invited by the Academy to come here this evening to chair this evening's discussion on a really incredibly important topic, and one that's very close to my heart, the education of the engineer. And as I look around the room, it's fabulous to see so many of our brightest stars, or so I'm told. I've met some of you. I look forward to your tremendous, bright and challenging questions later on. And it's a real privilege to have the opportunity to step back from the things that I have to do day to day in running our company, so that I can sit with you and explore how we as engineers can deliver change right across our society, which we as engineers, of course, serve in so many ways. That brings me neatly to Lord Browne's headline mission as the president of our academy. And he set out a mission and a strategy with us to put engineering right at the heart of society. John, as your term of office draws to a close, this is a fabulous time for us to take the opportunity to note the considerable progress that we've made over the last 5 years. That progress is certainly reflected in the much better engagement of engineers in government policy making, a much better and broader engagement with the public, and especially with younger people and younger engineers. And we've certainly had a marked improvement in the profile that we as engineers have in our media. So, John, I'd like to take the opportunity to thank you very much for everything that you've done as our president, for your inspired vision and your leadership. And you certainly leave the Academy with a legacy that we all intend to build on. And you've set a path for us to follow, and we will follow strongly because there still remains a lot for all of us and all of you to do. You're a great engineer. You're a great business leader on the global stage. And tonight, I invite you onto our stage to give us a presentation. Thank you, John.
Thank you, Paul. Paul, ladies and gentlemen, good afternoon, good evening, and welcome to the Royal Academy of Engineering. I'm delighted to see everyone here this evening. I'm always delighted when I talk to see that people actually arrive, and in particular this audience, some of the best engineers of this generation, on your way to becoming the leaders of our profession. As a young man, I chose engineering because I wanted to make a mark in the real world. I imagine many of you are driven by the same goal. Tonight, I want to explore what skills equip an engineer to maximize the impact they have on the world around them. In other words, what makes a great engineer and how do you educate one? Before we discuss this question, I'd like to point out that this evening is part of the celebrations of the 35th anniversary of this academy. In 1976, the founding fellows met at Buckingham Palace for the inaugural meeting of what was then the Fellowship of Engineering. And this is a photograph of them. They look very distinguished. They're actually, I think, all men. And therein lies some other issues. But among them are Prince Philip, our senior fellow, Earl Mountbatten of Burma, and 128 other distinguished engineering leaders, including Barnes Wallis, the inventor of the bouncing bomb, Ove Arup, the great architectural engineer, and George McFarlane, the pioneer of radar. Their vision was about how engineering can best be promoted for the national benefit, for the progress in wider society, and for the future of humankind. I've had the pleasure and privilege of serving as president of the Academy for the last 5 years. Next month, or this month, I hand over to my successor, Sir John Parker, and I want to briefly reflect on how we're working to realise the vision of our founding fellows. Through its fellowship, the Academy has been fostering a much better understanding amongst the public and opinion formers of what engineers do and what they can achieve. We work to ensure that engineers are recognised by policymakers as essential to addressing the challenges we face. And we're supporting the kind of research and ideas that businesses can turn into value for society. There's still a long way to go, but I think we've made real progress towards the vision of our founders. Most importantly, we're helping to create an education system that inspires and encourages young people to choose a career in engineering and equips them to become the great engineers in the future. Throughout my career at BP and here at the Academy, I've worked with many great engineers and seen them achieve a wide range of extraordinary things. Whether it's constructing a 1,000-mile-long pipeline in Central Asia, developing breathtaking 3D geoimaging software, inventing revolutionary games consoles, or developing innovative forms of solar power, these engineers have made significant contributions to the progress of humanity. To me, these achievements are striking not only for their diversity, but for the common capabilities that have made them all possible. I believe that successful engineers share certain characteristics. In particular, I believe a great engineer is 4 things: an expert with a broad base of knowledge, a strategic thinker with an eye for detail, an innovator, and a communicator. The education of an engineer should be designed to instill and develop these skills. Last month, I was in Beijing at a conference to discuss innovation and low-carbon growth. There we discussed the words of the Chinese philosopher Lao Tzu, who said, all difficult things have their origin in that which is easy, and great things in that which is small. You have to think about that. That's certainly true for engineers. Every great engineering accomplishment is built on the technical mastery of a specific discipline. But to my mind, specialization for an engineer shouldn't come at the cost of broad understanding. In the real world, engineering challenges don't come neatly labeled civil, mechanical, or electrical. In fact, the most innovative solutions often emerge when ideas from these separate disciplines collide. A good example is a recent winner of the Academy's McRobert Award, the iLimb, a prosthetic device that looks and acts like a real human hand. It has 5 individually powered digits, heralding a new generation in bionics and patient care. That innovation was made possible by bringing together cutting-edge mechanical and electronic engineering with groundbreaking software and state-of-the-art plastics. Of course, it was designed by a team of engineers, each of whom had their own specialism. But success relied on communication and coordination between them. It required that each understand the technical language used by the others and the basics of each field. An engineer can't be an expert across the board, but a great engineer is equipped with enough knowledge of each field to understand how the system operates as a whole. There is, I think, an analogy here with physicians. We recognize that before a doctor can specialize, they must understand how the whole body the whole system works. In my view, that same breadth of knowledge should underpin the education of the engineer. But of course, engineering is about far more than knowledge. An engineer's core business is to turn theory into practice, to translate scientific progress into commercial and social value. And that requires more than technical competency. It requires an ability to juggle the competing demands of a project, managing risks, controlling costs, and keeping on time. In other words, it requires an ability to combine high-level strategic thinking about a system with a scientific precision on specific issues. For example, when I was at BP, we built the BTC pipeline shown here, stretching 1,000 miles from the Caspian Sea to the Turkish Mediterranean. The technical challenges were legion. The pipeline climbs up to 3,000 meters, crosses 1,500 rivers and roads. It had to be buried along most of its route and negotiate 5 significant seismic faults. That project was delivered on time and on budget, not only because BP's engineers were technically excellent, but because they were among the best in the world at managing a complex project subject to numerous commercial pressures. As the Academy's research has shown, that ability to think strategically can't be learnt from a book. It has to be developed through practical experience. It can only be achieved through learning by doing, getting students to work on real engineering problems and properly considering the consequences of their approach. In an increasing number of universities, this process is guided by real-life expert practitioners, the Academy's visiting professors. Senior engineers from industry, including from these great companies, are appointed as visiting professors, each to enrich the undergraduate curriculum with experience from real-world engineering problems. Feedback suggests that they're actually making a real difference. In my career, I learned a lot about strategic thinking from great people who took time to coach me. I also learned a lot from my setbacks and failures. And learning from mistakes is at the heart of another great engineering education initiative, the Constructionarium. Students are given access to what is essentially a building site, with real equipment and staffed with real construction professionals. They're given a project to build, in this case, a scaled-down version of the Gherkin, and then essentially left to get on with it. They get to apply their theoretical knowledge in the field, and crucially, they get to make mistakes. They develop the capacity to integrate the technical, operational, and business aspects of the job. Practical education like this is expensive, but the benefits to young engineers are very valuable indeed. Learning by doing breeds another skill in engineers, the ability to innovate. Successful engineers are not only competent, they're inquisitive, interrogative, and creative. And these skills can't be taught. There is no recipe for innovative thinking. But it is possible to create an environment in which innovation can grow and flourish. And last month, I met a man who knows just how to create such an environment. Kai-Fu Lee used to be the head of Google China, and before that, Microsoft Research, and has now set up a company called Innovation Works. It's a pun. An incubator for young Chinese companies. He's got a portfolio of more than 30 companies, and each CEO is below 30. And all are producing applications for Android phones. So far, only 2 have failed, and many are enjoying great success. And incidentally, the applications, of course, are much richer in that a Chinese character is worth 5 Latin characters. So 140 characters is a lot of information. According to my reading of his analysis, an innovative workplace needs 4 things. First, a leader who's ideally, in his word, a despotic founder, but is at least very strong-willed. He or she must be able to give the company a single clear purpose. Second, supportive staff. In his case, these are the very best engineers in China, intelligent, hardworking, and creative. They're encouraged to constantly challenge one another with new ideas. Third, aligned incentives. Paying people according to the success of the company ensures that innovation is rewarded. And fourth, tolerance of failure. Innovation depends on taking risks, and failures are an inevitable byproduct. They should not be punished. In my view, his analysis is spot on, and it applies just as well to education as to the workplace. We must create a learning environment in which students are encouraged to challenge received wisdoms, in which examinations reward novel solutions to old problems, and in which students have no fear of making mistakes. Minds are naturally full of great ideas. An education system that allows those ideas to flourish will create the innovative engineers of the future. Now, two important trends mean that those innovative engineers will be able to change the world more rapidly and more dramatically than ever before. First, more and more innovation takes place in the sphere of applied engineering rather than fundamental science. In the past centuries, the great innovations were intellectual, gravity and electricity and so on. Today, they are technological or organizational. They're in the domain of the engineer. Second, innovation spreads more quickly than ever before. As this graph shows, it took at least 100 years for printing to gain 50 million users, whereas the internet achieved the same success in only 4 years. And in the last 4 years, Africa's internet capacity has grown from 34 gigabits to 34,000 gigabits. In an advanced and connected world, a single great idea can have the most incredible impact. The final crucial engineering skill I want to discuss this evening is very different, and it's the ability to emphasize and communicate. As my colleague Lord Darcy has put it, engineering is about finding technological solutions to human problems. That means engineers must appreciate the social, political, and even emotional context of projects and design solutions that meet those human needs. They must be able to explain the benefits that a project can bring in order to align diverse parties behind it. So I come back to the BTC pipeline project, once again a good example. The route crossed 3 countries, Azerbaijan, Georgia, and Turkey, and impacted more than 100 different ethnic groupings. In total, some 750,000 people in 450 different communities were affected by that construction. We knew that the success of the project would depend on the support of those groups. There had to be economic, social, and environmental benefits for all involved. Engineers working on that project had to understand the human context of their operations, to listen to local stakeholders, like these BP workers, to design the pipeline to meet their needs, and to explain its benefits to all those affected. The ability of the engineers to do so was essential to success. In the UK today, the situation for engineers is very different, but the need to act as a communicator is just as important. There are few areas of policy, for example, that don't have an engineering dimension to their delivery. An increasingly important focus of the Academy is to actively get involved in designing policy. So earlier this year, for example, we convened a roundtable of industry experts to talk about the barriers to a flourishing offshore wind supply chain. In areas like this, engineers have got to be aware of the political and human implications of their advice and proposals. Technical perfection is insufficient. At the Academy, we're also working hard to convey the human impact of engineering to the wider public, especially younger people. We promote engineering in the media every week. We attend festival events and debates. We help run the Big Bang Fair, now in its 4th year, which reaches 25,000 young people, not enough. And we are closely involved in the introduction of a new International Engineering Prize announced recently by the Prime Minister. Not only does that raise the profile of the profession and its work, but it inspires the next generation to choose a career in engineering. So to conclude, I believe that it's time to reconsider what constitutes the skill set of a great engineer. And I think there are 4 crucial ingredients. First, a broad-based technical competency. Second, an ability to think strategically, breaking down a challenge into component parts, understanding the commercial constraints, and managing risk effectively. Third, a willingness to question and disrupt accepted norms, an ability to bring new ideas and innovation. And finally, a sensitivity to the human context of every project and a capacity to build support. Together, these add up to create not only a great engineer, but in fact a great leader, whether in business, politics, or academia. In my lecture last week on resources for humanity, I set out what I believe leadership means. I said that being a leader requires you to do 3 things: define your vision, align your team behind you, and execute your solution. The education of an engineer, as I've described it tonight, equips an engineer to do just these 3 things. An engineer who's learned to question accepted norms, who's spent their career developing new ideas and embracing the risk of failure, is a leader equipped to define a bold and radical vision. An engineer who's learned to understand the human context of every project, who's worked at building teams and support inside and outside their business, is a leader equipped to align an organization behind a common goal. And an engineer who's learned how to think strategically while considering the details, who's practiced by making mistakes and solving problems, is a leader equipped to execute solutions with control of costs and risks. That's why I believe that engineers who hone these skills, who equip themselves as leaders, have the ability and opportunity, more than any other profession, to make an enormous impact on the world around them. That applies not only to all of us gathered here tonight, but to the next generation of engineers yet to complete their education. In my view, it is the duty of every professional at the right point in their career to pass on their expertise and experience to the next generation. I hope many of you will do just that when the chance arises, whether through employers, professional bodies, or universities and schools. Ladies and gentlemen, that now concludes my formal remarks, and I hope I haven't presumed on your patience, but now it's time, I think, to share your thoughts and ideas and feedback. Thank you very much.
That was fantastic and stimulating, and I enjoyed it tremendously. So now we get to the fun part, where we get the opportunity to ask some questions and maybe stimulate a little bit of debate and discussion. And for those of you with whom I've planted a really tricky question, now's maybe the... No, I'm joking. We have a few questions that people have sent in already, and we'll start with those. We have 3 here, and then we'll go to the floor to allow you the opportunity to get stuck in. There are some microphones. Where are the microphones? Wave the microphones around. There we go. Some microphones at the back, 1 in each aisle. I would ask, initially with the 3 questions that have already been submitted, that when you get the microphone, you introduce yourself with your name and your company or your affiliation, and then launch into your question, and away we go. So without further ado, our first question is from Laura Grimmett. Is Laura in the room? There we go. Laura, the floor is yours.
Hello, I'm Laura Grimmett from Work for BP. I have a few years until my children start to think about university, and I'd be really proud if they chose engineering as their subject. However, I'm already starting to think about the cost of sending them through university so that they can graduate with a good degree, and whether they will actually want to go to university, given that they're likely to build up large debts. What do you see as the main selling points for young students considering a degree in engineering, given that good engineering positions are limited?
So, first, let me say thank you for the question. I'm going to answer it broadly and then narrowly. In the proposals that I was behind and I support about the change of the way in which universities should work and how students should be funded, the single most important thing in my mind was to improve the quality of higher education, which is very good in this country at the top, but it can always get better at the bottom. You know, constant continuous improvement and high grading is always the way to go. So that was very important. Competition, therefore, is critical in getting universities to hone their skills, hone their offering, and do the best job for students. That costs money, and clearly the question then was who's going to pay, and the answer is a bit of everybody. The government's going to pay, charities are going to pay, and students are going to pay. Importantly, please remember, parents do not pay. Parents do not pay a penny. Everything is taken care of by the loans the government give to a student, which are very low-cost loans. They're the sort of loans that no one else could ever conceivably give. And the important thing about them is they're not repayable unless people earn money. And then they're repayable at very, very low rates, until the amount of money earned every year becomes very, very large. So in the £100,000 plus area, begins to get accelerated upwards. But that's probably a sign of pretty good success. Now, what do I think this is going to do to the education system, higher education system in the UK? In England, I should say. I'm only allowed to talk about England. In England, I think first we will have more competition. So universities will think very carefully about what they're offering to students, how they're delivering it, and what the quality of the output is, as well as the quality of the input. They select the best, they've got to get the best out there. Students, I think, will think about what sort of degree to get, depending on what they want to do in the future. And I think they won't be independent decisions anymore. There'll be more dependency. And I think that's a fact of modern life, right around the Western world, I think, that students have to think a bit more carefully about what am I going to do when I leave, not just what am I going to do when I'm there. And I think, given the maturity of everybody now, which is people get mature in their thinking earlier and earlier, it's clearly something that people can do. So I think those who choose engineering will, I think, be affected by the following. First, statistically, it's one of the highest earning professions in the UK. Secondly, it is a profession that has a growing requirement for engineers, and the data seems to show that we always seem to produce not as many as we might need, although I think supply and demand always meet by definition. So, but we are increasing the number, but they're very sought-after jobs. And thirdly, they have to think about the sort of engineering job they want, and do they want to use it directly or indirectly, the leadership skills it gives. So I think people will think a lot about what do they do when they leave. I come back to what I said this evening. I do think, above almost any profession, engineering gives people an extraordinary insight into leadership very, very early indeed.
Thank you. Laura, any comments or your right to reply?
No, thank you. That was...
Thank you very much indeed.
Thank you. Very helpful.
Right, second question. Duncan Manning. Duncan, you pop your hand up.
Hi. Question for Lord Browne, please. The Chief Operating Officer of Defence Equipment and Support within the Ministry of Defence said that one of the biggest challenges within the defence industry was finding people with a strong enough technical background to take on the highest level directorial and executive posts. Is this a problem that you're familiar with? And if so, what can be done to better prepare engineers for these roles in the future?
So the answer is yes, it is. And I think but I cut it slightly differently. What I've observed, and I'm doing a reasonable amount of I'm giving some advice to the government independently. I remain independent of all governments. I will always do that. I think when you work for someone the whole of your life, you never want to work for anybody ever again. It's just a tip for the future. So it seems to me one of the things I've observed is the great separation between those who come up with what should be done and those who actually have to do what needs to be done. Think of it as the people with ideas or directorial policy and the people who have to deliver. Now, it doesn't mean to say that everybody who knows how to get something done, an engineer, let's say, who's a great project engineer, should always become the CEO of every company or the head of every division. But enough of them do in order to cross-fertilize, and I think to gain the respect of those who don't know about this, because otherwise you can see really bad things happening. Project management, major projects, still go wrong in industry as well as government. And the diagnosis always is that those who direct them have insufficient authority and standing to really explain the risks to those who are making the final decision. And it's about truth in forecasting. An overrun could be an overrun, or it could just be a very bad forecast initially. It could be a very bad team construction. So having enough people who know what they're doing, who really have deep experience in delivery, with enough people who know some other things. They know about politics, they know in business, they know about trading, finance. Having that mix, that balance, is so important in a company. And you keep running out of the people who know what they're doing on the delivery side, because everyone's been attracted from time to time to the more glamorous option of finance or policy or something. And we have to rebalance the attractive. It's tremendously attractive. And actually, when you do, as I'm speaking to probably to the converted, but when you actually when you can do something and deliver something from your own actions with a team, it's enormously satisfying. It's enormously satisfying. And I would suggest it's more satisfying than many other things people do in business or government, which is to propose options to people. And proposing options is great, but actually getting something done is much better.
I would certainly agree with that. Duncan, any... Good, thank you very much, Duncan. And our third question that was provided for us in advance is from Janice Turner. Janice, are you around? There we are.
Hi, I'm Janice Turner from FREng. Unfortunately, my question is very similar to the first question.
Ask it again.
I'll put a slightly different spin on it. It's more about you're looking at an engineering degree. They tend to be 4 years compared to many others, which are 3. From a student from a less affluent background, actually looking at it 3 or 4 years if they're determined to go to university, how can we ensure they don't take the choice based on monetary actions rather than their love of engineering, given the financial considerations? Right.
So my recommendations, and I don't know whether this is really going to happen, were that very expensive programs also contained a further subvention from the government to put them on a level playing field with those which are not so expensive. So the classic is veterinary science. To become a vet takes an awfully long time, and you don't have the NHS behind you. If you're a doctor, you have the NHS, and they do lots of other things and pay for the latter part of your education. A vet needs help. If we're going to have vets, we're going to have people who are exposed to the same risk, as it were, as everybody else, and the rest of the risk has to be taken up by the government. So what I proposed, what my commission proposed, I should say, is to give an agency a chunk of money, a large amount of money, to look at these very expensive subjects and do something about it, in particular for the students. So I think, and that's what you have to do. There are some things that just, markets don't take care of, and that's one of them.
Thank you. Right, here we go, free form. So hands up for a question. So who's going to go first. With a microphone over there, please. If you could just let us know who you are before we get going.
Shane Maloney from Babcock. You mentioned about the need for an engineer to consider the social and political and human aspects of their role. But it strikes me that politics is dominated by lawyers and accountants and economists. And it's a question that I've always asked myself is, why are there so few engineers in politics? And I just wondered whether you'd like to offer an opinion on that.
Well, I think the answer is I don't know, but I can speculate that given the amount of time it takes to get into the profession, I think people get very interested in what they're doing, and they don't think about doing something like politics, which needs a slightly different mindset early on, I think, to want to go into. So I think people divide early in what they're really interested in. My point was slightly wider. I think, for example, in industry, many people say that the capital markets are cruel and a very bad place that never allows you to do anything which is right for people and right for the environment, right for society. It only has to be right for the shareholder. Now, like all statements, they're partly true and partly false. The partly false, I think, is this, and what I meant by that is engineers can have a great sense of what actually works over the longer term. And investing in the societies you're working with, doing things in the right way as opposed to the wrong way, making something which is sustainable, which is green where you can, might actually allow you to stay in business for much longer. Because when you start disrupting people in particular, they say, well, so you're in business, are you? Well, we gave you permission to be in business, and you're misbehaving, so we'll take that permission away, or we'll do something to you that you won't like not give you permits or shut you down, do various things like that, or if you want to come and ask again, the answer will be no. So it's those things, I think, where you have to think about the whole system of business in particular, the whole system of business, which takes, I think, an engineering thinking process to see what needs to be done and how it needs to be done. So that was my second point there.
Thank you very much.
Right, we're getting a few hands up here. If we start over here with you, and then we've got you over there in a minute.
Hi, Jeremy Viner. You showed us towards the beginning a photograph of some distinguished gentlemen, I think you referred to it as. But and you pointed out it was all gentlemen in that there were some issues. How well do you think those issues are tackled today, if we have them, if you believe we have them, and if we do, then how do you think we should tackle them?
Well, not particularly well. Much better than the past, I would say. But there are still many things that need to happen. First, I think custom and practice. There's so much custom and practice around where people, for some reason, say, well, this is a male-dominated profession. I wouldn't do that if I were you. There are all little nuances that start changing the number of the gender balance of the input. And they're very subtle. And it's very easy, in my experience, it's really easy to adjust the opinion of a young person almost inadvertently. Even a joke will do it, and it'll put people off. And so I think there's a lot of custom and practice that upsets it there. Secondly, I think there's this myth that some things are only acceptable to be done by men, not women. That can't be right. It's just not right. Thirdly, I think we are not brave enough to use where we have to use targets to pull people through. I've been a great believer in this. I know it's not necessarily politically correct, but I believe it right for a period of time. It's to make the point. You need to get people, and we need to go search for them with merit. So if we don't get that right, then at the end of the pipeline, no one appears. People lose by not coming in at the beginning. They lose because they don't get the right job. They lose because they just get exhausted and say, actually, it's much easier to go into banking, really. Or banking was much easier. So as a result, the fellowship, which is, to become a fellow, you have to be invited and elected. You can't apply. So we have, I think, 3 to 4% of our fellowship is women. This is not enormous. But if you back calculate to look to see why, you can understand exactly why. To do with the number of people who came in quite a long time ago, because it takes time to become a fellow, and see how it goes. So we're very focused, and everything, I'm very concerned to make sure that we keep the pressure up, that we encourage, talent to come into engineering, and that means getting more women into engineering. Otherwise, we're stacking the deck against success. We're simply stacking the deck against success. It's getting better, but it's by no means there.
Thank you. Now we had one just over here.
Hello, my name's Peter Briley. I'm from London Underground. On Friday, I'll be giving a talk to some 15-year-olds about careers in engineering. I was just wondering what you would tell the children and how you would persuade them to take up a role in engineering.
15's a difficult, it's an interesting age. It's obviously on the cusp of becoming quite serious with public examinations and things like that. So I don't know what I would say. I think I would say you want to solve great problems. This is a great place to see extraordinary problems solved and give some examples. For example, if you just take the last 5 winners of the McRobert Award while I've been president, it has nothing to do with me. There's an independent selection panel. But they're great people. We did an extraordinary console from Microsoft this time, which allows you to image and mimic human action. We have the hand here. We have an extraordinary device to check the quality of the eye. All these things are interesting because they've got human applications as well as engineering problems. And I think that's the way to get people excited, is to show them some examples. Then I think when they're 18, and then certainly at university, I think talking about the leadership quality that comes through being educated as an engineer, I think is very attractive to people, because you can make a difference. You really can. And there are very few subjects that you can say to people, this is a subject that teaches you about leadership.
Thank you. I did see a flicker of a hand over there. There we are. You were next. Thank you.
Thank you. Hi, Adrienne White, ABB Engineering Services. Just a quick question on whether or not you believe the title engineer should be protected, because it seems the public image of an engineer is a man with a spanner, and whether or not if we actually protected the title, the public image would improve and you would get more women and more young men in, rather than thinking you're going to fix a boiler or fix a car.
Yeah. I think it's too late. And I'm not sure that the cost-benefit is quite right. And by that I mean, what would you do with the people who are called engineers today? Would you call them non-engineers or technicians? And you then, class society, would you really want to do that? Would you want to demean them? Because actually, it's the lifeblood of operations and maintenance, basically, whether it's in the domestic setting or offshore, So it's crucial part of the society of engineering. I don't know. I keep wondering why it is. Surgeons, remember, were barber surgeons and regarded as pretty ghastly people. You may still think they're ghastly, but they've done quite well in their understanding of change and reputation and title over time, without even having to be called doctor. Interesting. So I think that we need to work on just this. We are working with the professional bodies to see if we can have a registration exam for technicians called Registered Technician, which would cover everyone from a radiologist's assistant, so someone who actually understood how to use an X-ray machine and repair it, so high-end medical engineering, through to offshore activity, which is not doesn't require a chartered engineer. That's making some progress. But I think it's better to do it this way round, is to say, well, let's give someone a registration title. Let's not take away something and see what happens then in the development of the title. I have a feeling that's more human.
I haven't had anything from over this side. You need to earn your spurs. Just here, and then we'll come to you in the front in a minute. Yeah.
Hello, my name's Avijit. I work for GE Power and Water. I wanted to ask you about your opinion on universities collaborating with industries in the UK. Do you think there's enough collaboration? And if there isn't, what should be done to encourage that collaboration? Because my assumption would be that that would be very healthy.
So there isn't enough, and if you compare the UK with the United States, it's clear that there is a very big gap. And I think the fault has been on both sides, and it's a lagged system. I've in my business career, I've been heavily involved in trying to push, corporate participants and universities together, and it was very tough to start with. There were really unnecessary difficulties in discussing intellectual property. IP discussions got to the point of impossibility 10 years ago. They've got much better now. Then there was a question of cost sharing, because some companies think that you can take a free ride on a university. Someone's got to pay an overhead. They can't just pay per DM costs for investigators. So it's not a bargain. It's to do with quality. It's not to do with cheap. Cheap is easy. Just don't do it, really. So I think there were these problems. Then the academics themselves didn't understand the purpose. So no one set the context. And the business people thought the academics were having a cushy life anyway. So, it didn't quite work out. So context was missing. So I think it's getting better. It needs more work, and it needs more work right across the spectrum of universities. I think Cambridge, Oxford, Imperial, no issues, really. There are some minor issues now, but much more professional approach to things. And, there's spin-off companies, there are great incubators, all sorts of things. But in other universities, it's a bit tough. It's a bit tough. And it needs to get better.
Thank you. And we had just something here in the front.
Hi, Daniel Jarvis, Smith Switch Networks. Very similar overlap with that question. I was going to ask, do you think we need to add more business skills into our university courses? Specifically for my education, I was a software engineer or computer scientist. It's about 10 years ago. And looking back, I cannot believe how little I was taught about estimating, effective communicating, status reporting, and working in a team. I did one group project. And it's amazing how deficient my course was. Maybe you don't think that's necessary, but I wondered if you felt that that was something that needed more focus.
Well, I think someone has to do it. And the question is, how many things do you want to get into a 3, 4, 5, 6, 7-year program? I mean, pretty soon, it's going to be a very big amount of material. And if it's once over lightly, it's not going to actually teach people to think and to actually understand what's going on. So I think some of this should happen. Some universities are doing that. There are small modules of management which teach people a few things about how to project plan, how to assess economics and things like that, and the essentials of teamwork together. So step one in leadership. a lot of employers, and certainly I can only speak from my experience, took people and said, actually, for 3 years, we need to teach you about how to work as a manager and how to work as a leader, and importantly, how to respect people in other disciplines working together. And that's a purposeful program of education on the job. I prefer that because it's better to apply it as soon as you've learnt it rather than store it all up and hope you're going to apply it immediately, and you're not going to do that, and it's going to be lost. So it's better to do it, as it were, on the job with time out, but very important to do, I think, and to refresh, because once over doesn't work. This is continuous development.
At the back in the middle, please.
James Holloway, graduate civil engineer at Arup. I was actually originally going to further the previous gentleman's point, which was to say that when I was going through school and through sort of earlier years of university, despite having an interest in being keen and wanting to be a civil engineer, I always found the teaching of science and engineering and maths to be somewhat cold. And I have a feeling that it's probably not always been that way, and that perhaps our teaching of science and engineering has had some of the humanity taken away from it, if you like. It seems colder somehow. And perhaps relating to the previous gentleman's comment about needing kind of more diverse skills at undergraduate level, business management would be a good example. But simply perhaps the opportunity to study an outside course in the humanities would help to provide an extra depth, or perhaps an opening into learning about leadership, for example. And sort of slightly contrary to your previous point, the Americans managed to maintain a more diverse curriculum in their university education than we do, taking a broader range of subjects, and they still managed to...
It's true, but it's over a longer period of time. It's probably 4 years at undergraduate level plus 2 years at master's, and then you cover the whole lot. I mean,
okay,
probably that. But I agree with, if there's one point I would make out of your statement, and part statement, part question, is this, that I think in engineering and science probably, but I'm not qualified to speak in science, but in engineering, if what you're doing does not provide service to humankind, don't do it. It's got to do something for people, and positive for people. It's got to do something for people. And if you can't track from what you're doing to that point, something's wrong. Something's wrong with what you're doing. And, I would argue even in, Kevin Tebbett's been here, an old friend of mine, even in the defence industry, because it's about defence, not attack. But it's important to think like that, I believe. And that puts the warmth into engineering. Engineering is about people. It's about creating great teams of people to solve great problems for people.
Very good. Gosh. In here.
Thanks. Hi, I'm Sarah from British Airways. With all this talk of expensive degrees and stuff, would you advocate a young person going the apprenticeship route into the industry as opposed to higher education?
It depends what they want to do. I think that the key thing is to have choice and be realistic about the choice. There are full-time degrees, higher education. That's not the only way of doing it. But the model in everybody's mind about the start of higher education is a 3-year residential degree. I think we should go away from that. We should say there's different ways of educating people at undergraduate levels and at graduate levels. So part-time, that may suit people to a degree level. There may also be other, further education activity which leads to apprenticeship and a different form of qualification. It depends. It really does depend on ability, desire, and a thought of, what you're going to do. What you're going to do after it. It's not for everybody, actually. It's never been for everybody to do a residential higher education degree. But it should be for those who really want it and can do it.
Thank you. Over here with the, I was about to say the blue tie on, but then I can see about 4 blue ties. Just here, I'm looking at you. Yes, you. Yes.
Hi, Roger Cornish, Lloyd's Register. As a recent graduate, it's my opinion that projects at university are being stripped to a bare minimum in terms of funding because they're seen as a cost rather than a learning experience. For example, the university I was at had a very extensive research facility which was pretty much put off limits to undergraduates because it was too expensive for them to use it. How would, or what would be your opinion on how the engineering community could try and get that out of the educational system, as to me it seems counterproductive?
Well, if that is I'm sure it is the case, it is counterproductive. I think the academy, everyone, I'm in quite a different position, which is actually the education of the engineer should involve more solution of problems that require multidiscipline to do them. Come back to this point that, it's about physicians. I think if you went to see your local GP and they said, I'm sorry, I'm only involved with anatomy. You're cold, I can't take care of. You'd be very disappointed. And so the same with the engineer. Engineer has to understand how to integrate all these pieces. Our analysis of the education of engineering in the academy is that much more needs to be done practically, even if we have to focus down the number of universities that teach engineering. But to get the quality, it has to be more practical, should be taught hands-on, and actually some should be taught by the case method. In other words, case studies drawn up, which says, this is how this problem arose, this is how it was potentially solved, and then discuss it. And use that as the teaching method, because this is so important. What we don't really want is to create engineers who will not be able to meet their own expectations, who come out not able to solve real-life problems. I think it is a minimum qualification of an engineer.
Over here. Second blue tie.
Hi, my name is Mahesh Natarajan. I work with BP. Following on your statements around having more hands-on experience for engineers, should all engineering courses carry a 6-month to 1-year compulsory internship in industry to improve problem-solving skills, strategic thinking, and application?
I think it would be wonderful, but then you'd have to get the internships. And as you know, I'm sure, as everyone knows here, if you invite someone in for an internship, you better have thought through what they're going to do. And they need to be mentored and supervised, and that's a big investment. You can't just say, well, turn up and we'll figure out what to do with you, because that's deeply unsatisfying. So it's getting people to really do that. And I think some firms do, but probably not enough to make it a universal solution. It's a great thing if you can get it done.
Over here, blue shirt, not a blue tie.
Hi, I was interested in your answer to the gentleman somewhere on the left about why more engineers don't become leaders in society, go into politics or become politicians. And you talked about how the skills tend to diverge quite early on. So I was just interested whether you don't think that that's a problem, and whether we should not aspire to be sort of front leaders from the front in our society, rather than to some degree leaders from behind in developing technology, which is crucial, but we're rarely seen out the front, so to speak.
Well, I believe firmly that engineers should be right out front leading, not least because they're the people who can, in amongst other things, innovate. They can take invention and add commerce and create an innovation. So they can change things a lot, and they should be running companies and things like this. My main point was, in terms of going directly into politics, people tend to sort out early. I mean, there are differences, there are exceptions, but basically they sort out reasonably early. And I think there's a big job to be done in still pushing enterprise, corporations, to think through politically, with a small p, not big politics, think politically about their actions. Because every day I read the newspapers and I look at it and say, yes, I can see this, it's going to be bad, because someone's not taken into account all the things they should think about in the system, which is delivery. The system of delivery involves so many moving parts. That is politics, but it's not expressed in Westminster, where people end up with degrees in politics or economics or law, and they go there. And it's true in America too, although there are a few more engineers in Congress.
Right at the front.
Hello, Richard Stewart from Costain. You talked a lot about the leaders of tomorrow and the skill set that would be required from the engineer of tomorrow. And you also talked about a key skill being the ability to solve problems. I wonder if you had to pick one big problem from tomorrow that the leaders of tomorrow would have to solve, what it might be.
You should have been at my first of these. I basically said I thought that if we could solve the problem of provision of water and the provision of energy, almost everything else fell between these two bookends. So in order to be consistent, I would say solve the problem of water, solve the problem of energy. And they are related. One of the extraordinary facts is this, that 1 out of 50 barrels of oil produced is burnt in Saudi Arabia to make fresh water. Think about it. And that's today, not tomorrow. So this problem of providing energy on a sustainable basis to humankind and providing water on a sustainable basis to humankind, I think, are the two challenges I would pick for engineers to solve.
Very good. Right in the middle here.
Rashid Amin from NATS. I just wanted to reflect back on some of the work that you did as your term in the academy, and one of the points you mentioned was making engineering the heart of policy making. I was wondering if you could just touch that point a bit more, and whether I'm right or wrong in saying that. Does that policy making also look at sort of the bounds that engineering can go to? Because some of the sort of innovations that have come across, some people see as unethical, etc., etc. So I want to know what your view on that is, or do you see that still as unbound, and there's still lots more to explore?
So almost everything you do is bounded by a system of values, and you have to be very careful with all decisions have to be founded on really value-based leadership. Otherwise you go wrong, and you need to be very clear about that. So that's a boundary which applies to almost everything. What I'm very focused on, certainly with government policy making, is this. There is one thing about saying we must do something, and there's another thing about delivering it. And the gap between saying we must do something and actually delivering it with a known cost, on time, affecting the people you said it was going to affect and the way you expect it to affect, it's that bit which engineers are very good at. And if the proposal doesn't deliver, then the proposal itself needs to be changed. And this is something which I think most governments in the world recognize that they fall short, that they haven't thought about this. And I think the answer lies in history, where when there was plenty of money around and things were growing, you could afford to, try a few things out and, lose $1 billion here, $1 billion there. Pretty soon it matters today. It didn't matter then. Now it matters. And so concepts of, Six Sigma engineering, getting things done right the first time, thinking through things in a way which is really, using the minimum resources, very lean, all these things apply to policy making and its delivery. And that's an engineering approach.
Thank you. Now we've got time for probably squeezing a cheeky couple of last questions in, but you've been very patient over here, so we could get you a microphone. It's just coming. It's for the video machine.
Thank you. Phil Deacon, working offshore with Shell UK. I graduated from Cambridge last year in general engineering, then going into manufacturing and business. My tutors, therefore, prepared me very well for the 4 points that you commented on, and international exposure. However, 75% of my colleagues are now working for McKinsey, Bain, BCG, etc. So they trained us to become very good management consultants. Did my friends make the wrong decision and waste their careers? And what do we need to do on top of your comments in order to ensure that we don't just fill the graduate programs of McKinsey?
So there is, first, I mean, we should not allow that to happen based on ignorance and based on poor understanding of what is possible, even just poor understanding. A lot now is in the hands of employers. I think to explain to people that you can actually make real decisions, you can get involved in real things on a long-term basis and not be simply have a vicarious pleasure of offering people advice rather than doing something, be a principal rather than an advisor. People need to make that choice very clearly. And I think it's now up to employers to make a much better fist of explaining what it is you do when you join them as an engineer as opposed to a management consultant, and also to pay people appropriately. That's happening. I've noticed with great pleasure, I think in my old company, that master's degrees holders of petroleum engineering are now paid more than MBAs from Harvard, which is quite good. I think that still is the case. It certainly was a couple of years ago. So it shows the market is working. But I think explanation is key. But if I may, one of the things I see, I'm getting a bit old now, so a lot of people come to me and say, I want to change career. And they're often 45 or 50 in management consultancies or in investment banks. And they look back on their career and reflect on what they haven't done. They've certainly made a decent amount of money, but when you ask them, well, what have you actually done? They said, well, we helped someone do something. But they were never actually a principal. And that leaves a degree of a lack of satisfaction in almost everyone's mind. The ability to actually be a leader doing something, and I'm being very vague at that, but I think you know what I mean, it's a bad way of putting things, is a very important difference. And I think that's the thing that should attract people.
One last one before we close. Right over here on my left.
Tamara from Foster Wheeler. We're coming to the end of your leadership of the Royal Academy of Engineering, and reflecting and looking back, I was wondering, what do you consider to be the achievements of the Royal Academy of Engineering during your leadership, and what do you think is your legacy?
Well, first, I think all I've done is provide some, as I took the shoulders of my predecessor and stood on those, I hope I provided some strong shoulders for my successor to stand on in the future. My ambition was, we're 35 years old. It's very young in these terms, but is to get recognized as a place where good things happen, where great advice can be obtained, and where people would naturally come to talk about what engineering can do and do something about it. So I think we have done those things. We've had to find physical premises to do it. So we started with a few things to sort out: money, people, the usual sorts of things. And I think we've now begun. And in 315 years' time, I think we should be doing as well as the Royal Society.
Fantastic. And on that bombshell, we need to draw this part of our discussion to a close, and it falls on me to complete what has been a very easy and tremendously enjoyable task here, chairing the session, to say thank you ever so much to Lord Browne, and to all of you for your attendance and questions. And just to try and summarise things a touch, from bouncing bombs, radar and buildings, experts with a broad base of knowledge, strategic thinkers with an eye for the detail, but don't get lost in the complexity, innovators who are inquisitive and creative, but who require an environment from us in order to achieve that, expert communicators who can explain complex things in simple ways, engaging ways with empathy. And I really like the idea of balancing the tremendously difficult things of fiscal, environmental, social and political issues. Because for me, that's the definition of true sustainability. And that is the place where we can play. And we should never waste a good crisis. And there are certainly good crises coming, if I can be so bold as to suggest they're good. But energy price increases, water shortages, urbanisation, there are some big problems that we as engineers are going to have to step in and solve. And they are problems that aren't going away, and we will have to solve them. And it's a fantastic opportunity for us to take this middle ground, high ground, and lead by maybe disrupting things a little to shake things up. But Lord Browne, thank you very much indeed. And I think we have some drinks outside. Thank you.